Hey, it's Adam, back with another Python video. This time we'll be making the classic Breakout game with the Pyxel engine. We'll be using some sprites, doing some basic collision detection, state management, and more. I'll be using the free community edition of PyCharm for this project. First, let's create our new project. Let's give our folder a name. We'll be using a new virtual environment, and we want to allow it to create the welcome script, just so we can test our Python environment. Okay, this is the welcome script that we get in PyCharm. It will say, by the looks, "Hi PyCharm," but there's a breakpoint here. So let's get rid of the breakpoint by clicking on the red spot and click the play button up here, or Shift F10. Down in the console it says "Hi PyCharm." That tells us that our Python is working. Let's get rid of everything that's in here and work on building the scaffold for our game. First, we know we need to import Pyxel, the engine. And when we do that, we get the red cross because Pyxel hasn't been installed. What we can do is hit Install Pyxel, and PyCharm will collect it for us. See down the bottom, installing Pyxel. Done. Now the next thing we want to do is go to Tools, Sync Python Requirements. This will create a requirements.txt file which will make sure that our environment always gets the right versions of the dependencies. In one of my previous videos we didn't do this, and Pyxel did a major update, and some of the things in my video weren't working. So this time we're going to clamp it down. Just hit OK there. It automatically creates a new requirements.txt with Pyxel in there. This means compatible version, so version that's around there. Now you can close that file. The first thing we want to do is create a class for our game. I'm just going to call it app. First thing in our app class will be the init function. This is the constructor for the app class, so whenever we create an object based on app, it will run this constructor. We want to go pyxel.init, and we're going to need width, height, scale. Let's go 384 for the width, 300 for the height. Display scale equals 3, should fit a 1080 screen nicely. Title equals Breakout, and let's set our FPS equals 60. Now we always need pyxel.run. This tells Pyxel which functions to run every loop. So it'll run update and it'll run draw. We need to create those functions. So let's create update. Update's not actually going to do anything at this point, so we'll just put pass in there. That means it will just fall through that function without complaining. Let's do draw. All we want to draw at this point is, well, a black window, just to prove that Pyxel is working. So we'll go CLS, that's clear screen, and 0 is the color, which should be black. You might see the little wavy line under draw. It'll be saying that this method can be static. That just means that it's not actually using anything from the class. It will be later on, so we won't do anything about that for now. Now, before we can use our app class, we need to actually create an instance of it. So let's kickstart our app. If we hit play, I expect to see a black window. There it is. Our Breakout game's working. Now a couple of things with Python. If you don't put the right number of blank spaces before and after your classes and definitions, then you'll get little warnings. This one says expected 2 blank lines, found 1. You always need 2 blank lines above and below a class. Definitions need a blank line above. Now our game's pretty boring, so let's add a ball. To do that, I want to create a ball class. And instead of just putting it all in the main Python file and having our whole game in the one file, let's break it up into separate files to make it easier to manage. If I right click on the Breakout folder, I can go New, Python file, let's just call it ball. In here, I know we need to import Pyxel again. We're going to create a class called ball. First thing we need to do in there is create the init. And a new ball will probably want an X and a Y coordinate on our screen. In the constructor, let's set our local variables to the ones that we just passed in. Self.y equals y. We're going to want a ball speed, so we can tell which direction it's going and how fast. Let's call it speed x, and we'll just initialize it. Initialize it with some values. We'll probably change these later. We want a ball radius, 2 pixels wide should be enough. And later we're going to want to know when the ball is actually out of bounds, so when it drops out of the bottom of the screen. And we'll start it inbounds. Our ball class will want a draw function so it can draw itself. And we'll just draw a circle. Pyxel.circ wants the X and Y coordinates, the radius, and the color. I believe 7 is white. Later on we'll do an update function as well as some collision detection. But for now, this should allow us to create our ball and display it on the screen. If we go back to our main, we want to import our ball class. So from ball, import ball. And then in our app constructor, let's create a ball, an instance of the ball. Self.ball equals ball, and we'll set the location 100, that'll do. Now we want to actually draw our ball. So after we clear the screen, let's go self.ball.draw. So we'll call the draw function inside the ball class. Now if we run our game, we should see a circle on the screen somewhere. There it is. You can close the game window by pressing escape or clicking the X in the corner. Now let's make our ball move. Go back to our ball class. To make it move, we're going to create an update function. This will move the ball, then check if it should bounce. So if the ball hits one of the side walls or the top wall, we'll bounce it off. If it hits the bottom wall, as in it goes off the bottom of the screen, we'll set it out of bounds, and we'll do something special with that later. So to move the ball, we want to update the ball's X and Y coordinates. Self.x, we want to go plus equals, so this will add self.speedx, self.y plus equals self.speedy. Now if we go back to our main class, we can add our ball update function into the main update function. So self.ball.update. Now if you run our game, I think we should see the ball move. It will probably just fly off the screen. There it goes. That was pretty quick. If we adjust our Y speed, make it negative 1.5, it should move a lot slower. There it goes. Now let's get it to bounce. We want to check if the ball has reached the edges of the screen. We're going to use a few if statements for this. So if self.x, so the x position, plus self.r, the radius. So that means if the right hand side of the ball is greater than equal to, we can use pixel.width to get the width of the actual screen. So if the right side of the ball has reached the right hand side of the screen, we'll reverse the speed x. Equals self.speed x times -1. That will just reverse the value. If it's 10, it will make it -10. Now let's check if the ball has gone off the top of the screen. Let's do an else if, which is elif in Python. Self.y minus self.r. So the ball's y position minus the radius should be the top of the ball. If it's less than or equal to 0, we know it's at the top of the screen. So we should reverse the y speed. Speed y equals self.speed y times -1. Now let's do the left side. Else if self.x minus self.radius. So that's the x coordinate minus the radius of the ball. Should give us the left side. If it's less than or equal to 0, we know it's hit the left wall. We can bounce on the x coordinate. Let's just copy that, paste it in, it does the same thing. The last one is to check if it's fallen off the bottom. So elif self.y minus self.r. So if the top of the ball has gone past the height of the screen, which will be the bottom of the screen, we will go self.out of bounds equals true. Right now we're not going to do anything with that, but when we get to game state, we're going to need that. So now if we run the game, the ball should bounce. There we go, and it should fall through the bottom. If we set our x to a positive value, we should see it bounce off the right hand side as well. There you go. We'll need to do some more with the ball class later, so for now let's just leave it open. Next, let's create our paddle, the thing that we're going to use to bounce the ball back with. For that, we're going to create a couple of sprites, and let's create a folder to keep them in. I like to call it assets. Now we actually want to run a Pyxel command to open the Pyxel editor. If we go terminal down the bottom here, we can run Pyxel edit. Now I'm going to create a file, assets/resources.pixres is the recommended extension for the resources file. If we press enter, this is the Pyxel resource editor. Up the top you can see your sprite editor. This is the tile map editor where you can use your sprites to create maps. We won't be using that. Sound editor, later on we might do some of that. And music, you can create music out of the sounds you create. For now, let's create the paddle sprite. I like to leave the first one blank because if you do use a tile map, it generally uses the first one as the canvas for the background. So let's just leave that blank for now. Let's create our paddle. I think maybe orange for the edges. And, I don't know, grey for the center section, the bit that you're going to bounce the balls on. Actually, let's fill out this bit. There we go, so there's an edge. What we can actually do, Pyxel doesn't let us rotate, but it does let us flip sprites. So we can use this for both the left and right hand side of the paddle. But we'll need another tile just for the center of the paddle, so we can make it as long as we want and just keep repeating this tile. Alright, that's all we need in here for now. Let's make sure we save it. You can leave it open if you want. Just tuck it out of the way. Now in our app we want to actually load our resources file, so pyxel.load assets/resources.pixres. If you look in the directory over here, you can see the files there. It's been saved. Now we want to create a paddle class. So same as the ball, let's right click on Breakout, go new, Python file, call it paddle. And this one, we'll want Pyxel. Leave 2 spaces. Create our paddle class. Create our init function. Now the paddle will need a width. We're going to make it 48 because each of those sprites is 8 pixels wide. 48 divided by 8 is 6. So we're going to use 2 for the sides and 4 for the middle. We'll just leave a gap at the bottom so it stops complaining. Self.h equals 8, so that's going to be the height of the paddle, that's just the 8 pixels. Self.x, we need an x and y location. To start it, let's just put it in the middle, but down towards the bottom of the screen. So x, what we can do is pixel.width divided by 2, so that gets us half of the screen width. And then minus self.width divided by 2. So that will put the center of our paddle centered in the middle of the screen. Self.y, let's go pixel.height minus 50 pixels. That'll do. Now, because we're going to draw this thing and it could grow or shrink depending on how we update our game later, we're going to have a variable here called midsections. This is how many of the middle sections we want to actually put into our paddle. Now we need some variables to tell our game where the sprite is located. So self.sprite image equals 0. So that's the image in the sprite sheet. Self.sprite underscore width. This is the width of each sprite. Self.sprite, we're going to get the end piece. We're going to use U and V for the X and Y coordinates in the sprite sheet, just so we don't confuse ourselves later. So if you look at our resource editor, the end piece begins at 80. Look in the top right corner, you can see the location of the mouse begins at 80, and the mid piece begins at 08. So 8 self.sprite and V equals 0. Sprite mid U equals 0. V equals 8. Now we want to actually draw our paddle. So let's create a draw function. Now this is going to look a little bit long because our variables are a little bit long. But what we're going to want to do is place our left section of the paddle, and then place all the middle sections, and then place the right section. Remember, to place the right section, we're going to have to flip the sprite. I'll show you how to do that when we get there. So we can do pixel.blit BLT. Because this is going to be a bit long, we'll break it over several lines. It wants X, it wants Y, it wants which sprite image to pull the sprite from, and then it wants the X and Y coordinates of the actual sprite in the sprite sheet. So sprite and U. Oops, always put a comma on the end of these. Sprite and V. And then it wants the width and the height of the actual sprite, which are the same thing. For us, self.sprite width, self.sprite width. We use width again because they're both 8. So that should draw the left-hand side. Now let's draw the middle. For that, we're going to have to iterate over the number of midsections that we've got. So let's do a for I in, we use a range of 0 to self.midsections. Let's go pixel.blit. This is another long one. Let's break it over several lines. Self.x plus self.sprite width plus self.sprite width times I. So what this does is, for the X position, we're going the X position of the paddle plus 1 width, because we've already got the left hand side drawn in, and then we're going to add multiples of width based on how many times we've added middle sections. The first one will just be, width times I, which is 0, so 0. The second time it'll be 8, so it'll put them along from left to right. Self.y is easy, and then we want the same thing as what we've got up here. Image sprite. Instead of end, we're going to use mid. So let's copy that in and just update these, make sure they say mid. So we've got our image, we've got our mid, X and Y, and we've got the width. Now for the right section, it's almost identical to the left section. So let's copy that. Paste it in. Now we want to update the X coordinate because we want to put it on the end. So to do that, we'll go self.x plus self.sprite width plus self.sprite width times self.midsections. So X coordinate plus the width of the left-hand section plus the width of all of the midsections. And then to flip this sprite to make it look like the right hand side, we need to set a negative value for the width. So in Pyxel you can flip a sprite either horizontally or vertically by setting a negative value for the sprite width or height. So to do that on ours, we want to do times -1 on the width, and that should make that end section look like it's on the right hand side. Now we'll have a paddle. It'll be able to draw itself to the screen, but it won't move. Let's add it to our game just to test it. So from paddle import paddle. Let's add it under our assets. self.paddle equals paddle, and let's draw it before our ball down here. Self.paddle.draw. Now if we run it, I think we should see our paddle on the screen. There it is. And ball passes right through it. So let's add some collision detection. Close our game. We're going to want to add our collision detection into the ball class, I think, because we're only really checking if the ball has collided with something else. So underneath the update function, let's create detect collision. Now we're going to make this a little bit generic because we want it to be able to check if it's collided with the paddle, but also later on check if the ball has collided with one of the bricks. So I'm going to pass it an object, which could be the paddle or it could be a brick, and we're actually going to express whether we're telling it that we want to check the paddle or not. Now because the ball could possibly move very fast, faster than our frame rate, so it might move faster than say 8 pixels in a single frame, it's possible that the ball could actually pass through a brick or through the paddle. So what we want to do is break up that movement of the ball into smaller sections and calculate whether those individual sections have actually collided with anything. That way the ball can't actually pass through something without us noticing. So first thing we want to do is calculate the number of, sub-steps for the continuous collision detection. So num steps equals, get that in the right spot. We're going to use seal, which will bring whatever value comes out of this equation up to the next whole number. We want max of the absolute value of self.speedx and the absolute value of self.speedy. It's telling us that seal is unresolved, so we need to import it up the top here. So from math, we're only going to import a couple of little bits. We're going to need copy sign a bit later on, and we'll also need seal. So let's import both of those. And now it's happy. So this will round up to the next whole number, the maximum value out of speed x or speed y. Right? So absolute returns a positive number, whether it's negative or positive. So if this is -1, it'll return 1. If this is 1.5, then it'll be 1.5. Maximum means it will return the largest of these two. Seal means if it's 1.5, it will round it up to 2. Now, if the number of steps is equal to 0, so if we don't actually have any steps, then the ball's not moving. It hasn't moved. So we're going to return false. Now, we actually want to check for collisions along the sub-segments. So we've segmented our movement of the ball into subsections, steps, that we can check and make sure it hasn't collided with something along the way. Check for collisions along the sub-segments. So for step in range of 1, number steps plus 1, So we're going to go through all of the steps that we've created. Actually, we want to work out our step size now that we've created our steps. Calculate the step size for each subsegment. So step size equals 1.0 divided by number of steps. Okay, now we need our interpolation factor. So T equals step times step size. I'll give it a little comment. You have to put 2 spaces before an inline comment, otherwise it complains. Now we want to get the ball X and Y of this current step. So we're going to call it sub ball X equals self.x plus interpolation factor times self.speedx. Sub ball Y, same thing, self.y plus T times self.speed Y. Now, we want to check if this subsegment has collided. So, this is going to be a bit of a long if statement again, so let's break it up. So if sub ball X plus self.radius is greater than or equal to the object dot X. So if the ball plus its radius, the right hand side of the ball, is past the left hand side of the object, and the left hand side of the ball is less than or equal to the object X plus the object width. So if the ball's left hand side is basically inside the object, if it's left of the right hand side of the object, and the top of the ball plus the radius gives us the bottom of the ball equals, so if the bottom of the ball is greater than or equal to the y coordinate of the object, so the top of the object, and y minus self.r, so the radius is less than or equal to object y plus height. Fix up that typo just there. So if the right of the ball is greater than or equal to the left of the object, and the left of the ball is less than or equal to the right of the object, and the bottom of the ball is greater than or equal to the top of the object, and the top of the ball is less than or equal to the bottom of the object, then we've collided. Now, because we're only doing paddle collision at the moment, we want to go if paddle. Ultimately, we want where the ball bounces on the paddle to influence the angle that the ball bounces off of. So if you hit it on the edge of the paddle, it should go at a sharper angle. If you hit it in the middle, it should go pretty well straight up. We need to create a function in the paddle for that. But for now, let's just bounce it off back up towards the top of the screen just to test it. So speed y equals self dot speed y times -1. So we're just bouncing it back. We also want to return true because it has bounced. Now if we get through all of that, the whole loop, the ball hasn't bounced, we will return false. So we know that the ball hasn't bounced. So collision detected, no collision detected. And let's just update this one as well. Ball is not moving. Okay, so for detect collision, when should we do that? We need to come over to main. We should do it in our update. But because we want to be able to check for all of the bricks and we want to be able to check for the paddle, let's create a new function in our app class called check collision. Just so that we can call this every time. Ball versus paddle. We want to get the collision. We want to see if the thing has collided. We're doing it this way because later on we're going to get the score as well, because different bricks are going to give us a different score. That's why we're creating a variable called collision, and then we're going to check if it did anything. So self.ball.detect collision. We want to pass it the paddle so that it can check the coordinates of it. And we want to say paddle equals true because we're actually checking the paddle. So if collision, right now we're not going to do anything. Later on, we're going to increase the speed of the ball every so many bounces. So we're going to have to do something in here. So up in update, after we've updated the ball, I want to check for collisions. Self.check collisions. Now if we run our game, if the ball happens to hit the paddle, it should bounce back off. Boom, there we go. Now we can't move the paddle yet. Now I want to be able to bounce the ball at a different angle depending on where it hits on the paddle. So in the paddle function, let's create, in the paddle class, let's create a new function called Deflect Force. U will be the x coordinate that the object has hit the paddle on. This will turn the deflect force of the ball on the paddle. Spell it correctly. So force equals, here we go, so U is the x of the object minus self.x plus self.width divided by 2, and then with a factor of 20 divided by 20. So the paddle x plus its width divided by 2, so that's the center of the paddle. If you take the object x, so the ball, its x coordinates, minus the center of the paddle, you'll get a plus or minus depending on whether it's on the left or the right hand side of the paddle. And then we're going to divide that value by 20 so that we don't bounce the ball off at ludicrous speeds. We want to return force. Now where do we want to call this? Probably in the bounce, the collision function, right? So down here where we're bouncing the actual ball, let's do the speed x as well. So self.speed x equals object.deflect force self.x. So the new Deflection Force function that we've created, we're going to pass it the x coordinate of the actual ball. And what it returns will be the new x speed of the ball. So let's try that. Now I believe the ball hits the right hand side, so it should bounce back and towards the right. There we go. Cool. If you want it to bounce at greater angles, adjust this value here. So if we make it 10, it'll bounce at a different angle. So that way you can make sharper angles towards the outside of the paddle. That's actually not too bad. Let's leave it at 10. Now I want to be able to move that paddle. And I think the easiest way to do that is to get it to track the mouse location. So let's create an update function in the paddle class. Update. Let's just state what we're going to do. Move the left and right on the mouse location. Clamp it to the edges of the game field. Clamp it to the edges of the game field. Okay, so we want to set the x coordinate of the paddle, right? So self.x equals min pixel.width, spell it correctly, minus self.width max 0 pixel.mouse x. So let's go through what this does. So pixel.mousex is the x coordinate of the mouse. Max gets the highest value out of 0 or the coordinate of the mouse. So that means if the mouse travels to the left of the game screen, it will go into a negative value. So instead of returning where the mouse is, it'll return 0. That will make sure our paddle doesn't ever go off the left hand side of the screen. And then pixel.width is the size of the screen minus the width of the paddle. So we want to make sure the paddle doesn't go off the right hand side of the screen. We want to get the minimum value of either the right hand side of the paddle, the right hand side of the screen minus the width of the paddle, or the location of the mouse. So that should clamp it between the edges, left and right edges of the screen. Now we need to run our update function in the main section. Let's do it before anything else. Self.paddle.update. Now if we run our game, it should track the mouse. There we go. It doesn't go off the left side, doesn't go off the right. We can bounce the ball. We hit it at sharper angles. We can change the direction of the ball. Cool. Now we want our game to do something if we drop the ball. I'd say we just want it to reset the ball. Let's put it on the paddle so we can fire it. To do that, we're going to need some game states. The game needs to know which state it's in to do different things. So I like to use an enum for this. So to do that in Python, we need to import enum. And we create a new class up here, leaving enough space. Call it game state of enum.enum. Now these are the game states we're going to actually need. We're not going to use them all right this minute, but we will need them eventually. We need ready, running, will be the game is actually running. Dropped is we've dropped the ball, let's do something about it. Game over when we actually add lives or number of balls that we're allowed to drop, we'll have to have a game over state. And let's have a win state as well, because let's face it, we're not going to give it infinite number of levels to play, and if you finish the last level, then you need to actually win the game and stop the ball from bouncing. Now, with our game states, we need to track what the current game state is. So in our init, let's go self.current game state equals, now because of that enum, we can do this, game state dot, let's call it ready. So we're going to be in ready state. What I want ready to be is the ball is stuck to the paddle. We can move the paddle, and if we click or press the space bar, I want it to fire the ball off. So to do that, we're going to have to do a few things by setting up the... Excuse me while this plane goes over. So to do that, we're going to have to do a bit of setup by setting the ball in the right location, setting its speed appropriately, and we're going to need some input as well to check when you've clicked or pressed the space bar. So instead of giving the ball the starting location here, I want to create a function that we can call later on. So if we drop the ball, we can call this function, we'll call it reset ball, and it will put the ball back on the paddle ready to roll. So let's go def reset ball, and here we're going to set all the initial values for the ball. So self.ball.x equals self.paddle.x plus self.paddle.width divided by 2 plus 10. So what that's going to do is put the ball in the middle of the paddle but to the right a little bit, so that when we launch it, it'll go off at an angle rather than straight up. Self.ball.y equals self.paddle.y minus 2. Now 2 is a magic number. Let's actually use self.ball.r, so the radius of the ball. Now we need the ball speed. Ball.speedx equals self.paddle. We're going to get our deflect force here. Self.ball.x self.ball.speedy equals, let's give it negative 2.5, so it'll launch towards the top of the screen, but not too fast. Now we want to make sure the ball is not out of bounds, so ball.outofbounds equals false. Now, these values here don't actually matter because we're instantly going to change where the ball is. So let's just initiate it at 0, 0. In fact, if we went to ball, find the initiator, we can get rid of X and Y. We can get rid of them here and just set them at 0, 0. So the initial values will be 0, 0, and then we'll instantly change it. So let's get rid of them here. There we go. So we can just call a ball, and then we can go self.reset ball. That will set all the positions and speed and whatnot for the ball. Now in update, we don't want to actually update the ball. We don't want it moving or checking for collisions, for that matter, if the game isn't running. So if we're in ready state, there's no point checking for collisions or trying to move the ball. So if self.current game state is equal to game state.running, then we'll update and we'll check collisions. And while we're in there, we'll also go if self.ball.outofbounds. Let's go self.current game state equals game state dot dropped. Now we're going to update the paddle because we want it to be able to move while we're in ready state. But we want to be able to update the ball position when the paddle moves. So if current game state is equal to game state dot ready, update, oh good, update the ball X position, it should be stuck to the paddle, right? So self dot ball dot X equals self, so it's the same as what we did in reset, paddle dot X plus self dot paddle dot width divided by 20 plus 10. So same as what we did up here. It's going to track where the paddle is. Just notice that should be 2 instead of 20. So if we check it now, the ball is stuck to the paddle. We can't do anything with it because we need some input detection. So just above our draw, let's check for input. Check input. So what we want to do is, while we're in ready state, we want to check if the left mouse button's been clicked or the space bar, and then we want to change it to running state, and that should let the ball move. So if self.current game state is equal to game state.ready, and then if how we check for mouse buttons or key presses is Pyxel.button P. So there's button and there's button P. Button is if the button is currently held. Button P is if the button has been pressed in this current frame. So what we want to do is Pyxel.mouse button left, or Pyxel.button press Pyxel.key space. Let's go launch the ball and set the game running. We can do that with self.current game state equals game state.running. Now we need to actually run this function, check input. We should do it in our update. In fact, let's do it first. Self.check input. Now if we run our game, we should be able to launch our ball by clicking. And then it goes into normal running state. Now let's start it again. And if we hit space, that also launches the ball. Clicking now does nothing. Let's do a little thing so we can see which state our game is in. We can add a line to our draw function. Pyxel.text. Let's go 10, and then Pyxel.height minus, 20. We want the string version of self.current game state, and let's make it white. Now that should draw the current game state in the bottom left of the corner of the game field. There it is. Game state ready. If we launch the ball, it should go to running. And if we drop the ball, it should go to dropped. There you go. Nice. Next, we should do something when we're actually in dropped state so we can recover from it. In our input, what I'd like to do is, if we're in dropped state, if you click the left mouse button or press space, it will reset the ball and set the game state back to ready. So in our check input, we want to go if self.current game state is equal to game state.dropped. Basically grab this. If the left mouse button or space, we want to go self.reset ball and current game state equals game state.ready. Okay, so if you drop the ball, it'll go into dropped state. And then if you click or press the space bar, it should pop the ball back onto the paddle, ready for another round. Let's try it. Launch our ball, let it drop. Okay, I'm going to press space. Let's put us back into ready with the ball on the paddle. Cool. Now, let's add some bricks to our game. So instead of us playing kippy-uppy, we'll actually have something to aim at. We want to go into our Pyxel editor. If you've closed it, you can use the same command in the terminal to reopen it. Pyxel, edit, assets, resources.pixres. Now, I want to just go to the next page. We actually want to create 4 tiles. But, let's go over another page, just create everything out of the way. Now, each tile will have different scores associated with them. For now, let's just create 1 tile. We're going to create our first tile as yellow. Now, I want these to be 32 wide. Okay, so each one of these is 8. So we're going to want to go 4 across. So let's use our fill square tool. And let's leave a little border around the outside of them. If you make a mistake, there's undo buttons up here. So if we do this, and then go 2 across, we can actually scroll, keep dragging it across here. And there we go. So we've created a tile that's 4 across. Let's save that. And just take note of the position. So starting position is 16, 0, and we know the width will be 32, and the height will be 8. And we're on image 0. So get your editor out of the way. We should create a brick class. So create a new file, brick. This one we want to import Pyxel as usual. Now, because we're going to have different brick types, they'll have different values. So they'll be in different locations on the sprite map, and they'll even have different score values. So let's create a type, brick type, and let's put everything in here so that when we create bricks, we can just say we want a brick 1 or we want a brick 2, and the code will just work out the magic. So a number 1. We'll have a image of 0. So we're going to have a UV width and height. So U is the X coordinate in the sprite map. It started at 16. V 0 because it's on the top. Width was 32. Height is going to be 8, and let's give this one a score of 1. We're not going to use the score just yet, but we might as well put it in there anyway. We'll come back and add more types shortly. For now, let's just get our brick class built. Class brick. Do the init script. Now, when we create a brick, we're going to want the X, the Y, and the type of brick that you want to create. With that information, we can set the X equals X, Y, let's keep track of the brick type in case we need to pull data from the type struct at the top. Self.width. Now here's where we're going to pull data the first time. So brick type, so the type that it's called in. We want to get the width. Same again for the height. In PyCharm, I'm just pressing Ctrl D to duplicate the line. Let's also grab the score while we're looking at it. Cool. Now we want to be able to draw this thing. So let's create a draw function. Now we want to blit it to the screen, so Pyxel.blt. It's a little bit long, so let's break it up. Self.x, self.y. We want the image, which is going to be brick type. Oops. Self.brick type image. We're doing it all this way because we're going to create an array or a list of all of the bricks in our game, and they could be any type in any location. That's highlighted because I forgot to put the comma there. Now we also want the x, y, width and height, so let's duplicate this. X, y, width, height, and then come through and update them. So we're calling it U, V, width, height. And that should draw the brick. For now, we're just going to manually put some bricks on the screen, but later on we're going to create level files and declare where the bricks will be on the screen. We'll load them in and create the array from there. So for now, let's go to our main function, import our brick class, so from brick, import brick. Now we want to create a bricks list. For now, let's just create a single brick. We'll call it brick at 100, 100, type 1. Now we need to draw them. So down in our draw function, let's draw it before the ball. Because this is a list of bricks, we need to iterate through all bricks and paint them all. So for b in self dot bricks b dot draw. So that should draw every brick in that list. Let's just start it up and see if we get our first brick. There it is. Now I can probably pass the ball straight through it, if I can actually hit it. Let's add a second one to the list. So same way, brick. Let's go, because they're 32, let's go 132, 100, type 1. Should be right next to it. There we go. Because they got the black border, they get the black lines between them. The ball passes straight through them because we have no collision detection for the bricks at the moment. To make sure our ball will hit the bricks, let's go and update our check collisions. Because we're not doing anything with the paddle just yet. Let's go to the next section, call it ball versus bricks. Now we want to actually iterate through all of the bricks in the list, and if we hit a brick, we want to remove it from the list. Because it's not safe or recommended to remove items from a list as you're going through it, what we can actually do is reverse the list and go in reverse order. That way if we remove something, it won't affect the rest of the bricks. So for I, this is the index, in reversed range length of self.bricks. So reversed will reverse a list. Range gives you, something between two numbers. If you only give it one item, it'll go between 0 and the other thing that you give it, so which is the length of bricks. Right now it'll be 2. What we want to do is just give us a temporary variable called b self.bricks I. So that'll be that particular brick at that index. We want to go collision equals self.ball.t detect collision. I want to do it against the object B, that brick. And if collision, we want to actually delete that brick. So delete self.bricks at that index. And then because we know that we probably haven't hit any other bricks, let's break that loop. Later on we'll add the speed up thing and also add score. But for now, I think the ball should bounce off the bricks. We've got a slight problem. It seems to go through the bricks, but it is colliding. So the next thing we need to do is, after deleting the brick, we also need to bounce the ball back. So in our ball class, under detect collision, we are only deflecting the ball if it hits a paddle. We want to do it also if it hits a brick. Now to do that, we need to determine which way to deflect the ball, if it's hit the top or the bottom, the left or the right of a brick. So we're going to use a else if sub ball x plus self.radius, so the right hand side greater than equal to object x, which is also greater than sub ball x minus self.r. So if the right hand side of the ball is greater than or equal to the left hand side of the object, and the left hand side of the object is greater than the left hand side of the ball, then ball hit left side of brick. So we want to bounce it back. There's a chance that the ball might actually be several pixels inside the brick. So let's actually move it back to the edge of the brick. So self.x equals object.x minus self.radius, so the radius of the ball. Right? Let's set the x speed in reverse. So self.speed x equals self.speed x times -1. Now we need to check if it's hit the other side of the brick. Sub ball x minus self.radius, so the left hand side is less than or equal to the object x plus object width, which is also less than, hang on, I made a mistake back here, less than or equal to needs to be together. So if object x plus object width is less than sub ball x plus self.r. So let's go through this again. So if the left side of the ball is less than or equal to the right side of the brick, and the right side of the brick is less than the right side of the ball, then the ball must have struck the right hand side, right? Ball hit right side of brick. So we're going to do the same thing, but we're going to place the ball just to the right of the brick. So self.x equals object.x plus object.width plus self.radius. Self.speedx speedx times -1, so just reverse direction. The other cases are it's either hit the top or the bottom. So we can either do just a single case where we check if if it's done everything else, then it must have hit the top or the bottom, so just deflect it. But we've still got the problem where the ball may have travelled a few pixels inside of the brick, and we want to bump it back out. Why is that important? Because if you hit 2 bricks right on the corner, it's going to check one brick for a collision, and then if the ball is actually inside of that brick, then it's going to collide with the other brick as well. We don't want it to be able to accidentally hit too many bricks. So let's check for top. So else if sub ball y plus self.radius, if it's greater than or equal to object.x, which is also greater than sub ball y minus self.radius. So that's if the ball hits the top. We want to self.y equals object.y. Hang on, I made a mistake up here. I've got x. Object x needs to be object y. So object y minus self.radius. And then deflect it. Self.y equals speed y. Speed y equals speed y times -1. Now we want to do the same thing again, but to check the bottom. So we want to check the top of the ball, so ball y minus the radius will be the top of the ball. If it is less than or equal to object y plus object.height, and object y plus object height is less than ball y plus the radius, so the bottom of the ball, then set the new y coordinate to be object y plus object.height plus radius, and bounce it back. Now, I believe that should be all we need to bounce the ball off the bricks. Let's try it. Bounces on the bottom. Might need some more bricks to test any more of this. Bounces on the top. Doesn't pass through. Cool. So let's create some more bricks, and then let's create some levels. Let's open up our pixel editor. Now the next 3 bricks, I believe we want to have green, orange and red to match the original game. So yellow, green, orange, red. Let's go get our green, do the same square thing. Let's just make it exactly the same as the yellow one. And then go down, grab your orange. And then down again, grab your red. Save it. We've got our 4 tiles. Let's get our editor out of the way. Go back to a brick class. And let's fill in the rest of these. I want to actually copy this. Let's put a comma there. Copy this. Let's grab, this will be 2. Call it 2. Now, we know that it's below the top one, so the X position will still be 16, but the Y position will be 8. Width and height are the same. Score. Let me just verify the scores for these. The score for the second brick will be 3. Now, brick 3 will be 16 down, and its score will be 5. brick 4. Will actually be 24 down with a score of 7. So we've defined the values for all of our different brick types. What we want to do now is create a couple of level files. I'll just be using text files. So if we go to our assets directory, right click, go new file. Let's call it level1.text. Now if we denote this as being columns and rows, so if we leave a couple of blank spots, it'll leave blank rows at the top of our screen. And because this is level 1, let's just make it easy. Now we can leave some blank spaces on the side, so 1, 2, 3, and go 1, 2, 3, 4, 5, 6. So this will give us 6 of number 1 type tiles on the first level. Save that file. Now because we're going to have multiples of these, let's create a manifest file called levels.text. And each line will just declare what that level file is called. That way you can use whatever you like for the name of your level files, just make sure they're updated in here. You can call one dragon, you can call one star, doesn't matter. Just put them in here and then the game will be able to find them and load them in order. So in our brick function, we're going to need a couple of things here to let the game actually load the manifest file and then actually load levels. Now these don't actually need to be part of the brick class, these are just going to be standalone functions, but because they're brick related, let's just put them in this class file anyway. Remember to leave a couple of spaces below your class. We will want a check levels function. And what it will do is load up that levels manifest file, read each line in, and return an array of everything that it's found. So found levels equals, right now it's an empty array. We're going to use with open assets / levels.text as f. If we use the with open method, it means when we've finished iterating through everything in this file, it will actually close the file for us. We don't have to muck around with it. For line in F, so it's going to pull lines out of this file. We want to get found levels.append, means we're going to put what we found on the end of the found levels. We're going to go line, and what we want to do is right strip that line because it will actually have a new line character, a hidden new line character in there. We don't want that. Just strip everything off the end of it. If you accidentally put spaces or something, they'll be gone. Right at the end, after we've finished iterating through that whole file and built up our found levels, let's return them. Return found levels. Now, to use this function, we want to go to main. Up the top, we want to import it. So this is part of brick. We actually want to change the way we import brick. We're not going to use the brick class directly. We're going to use one of our new functions to use the brick class and then return a list of all the bricks in the level. So instead of returning the actual brick class, importing the brick class, we'll get check levels. Come down to our init. Right under our load, we're going to go self.levels equals check levels. Now that will load all the level files into there already. You can see we've got some problems here. So let's change bricks to be none. So we're going to initiate bricks as an empty object. Later on, we'll load all the bricks for the level when we load the level. So back in the brick class, the brick file module, let's create our other load level function. You'll have to bear with the sounds of the aircraft. We live near a Air Force base. Anyway, so load level. Let's spell it properly so we don't get confused later. We're going to pass through the actual level file that we want to load. Now, this file will read in the level file, interpret the numbers that are in it, you know, 1s, 2s, 3s, 4s, as bricks, and then it will add them to an array and then return that array. So this level equals an empty list. We're going to give it something to look at every time it encounters a character in the file. It will check if it's a possible brick. If it's not, it'll ignore it. So if it's a space, it'll ignore it. If it's 1, 2, 3, 4, then it'll interpret that as a brick. If it's something else, if you put any other text in there, like you want to write your name in there, it'll ignore it. So 1, 2, these are the types of bricks that we can use. If you want to add more bricks to your game, you can, but you need to update this. And we want to load the level file. Load the level file and read through it, adding bricks to this level. So we're going to use the with open thing again. We go assets \. Now we're passing in the name of the level, so we'll concatenate that text with the plus symbol as f again. So we're opening the file as f. Now we want to keep track of the x and y coordinates here as we go through the file, so that we know where to put our bricks. So we'll start y at 0. Because we're reading from top to bottom, left to right, the y coordinate is each row as we go down the file, and the x coordinate is each character as we go across the line. So for line in f, we're going to set x to 0 as well. So for character in line, we're going to go through every character in the line. If character in possible bricks, we're going to append it, append a new brick at x, y, and we want the actual character, but we want to turn it into an integer because our brick types use integers rather than strings. So if we go int character, that will convert that character, which might look like 1, into an actual number. And then because we're moving across, we can go x plus equals 32. That's the width of our bricks. And under here we can move our y coordinate 8. That's the height of our bricks. And then when we're finished here, we can return this level. Now it's complaining up here because I didn't leave enough white space. Look at that. In our main, right at the top, we want to import load level as well so we can use it. Now while we're loading the level, I think it's a good idea to create a new function called start new game. We can use that right at the very beginning, and then if we ever reach game over state, you've dropped enough balls, then we want to be able to start the game again. So this would be a handy function just to reset our level, reset our ball position, and load the correct level. But we also need to know what our current level is. So let's create a new variable in here, call it current level equals none. I'm going to set it to none as well. I'm going to create a new function, start new game. The phone keeps going off because the cat keeps walking in front of the camera at the front door while he's looking for birdies. So what we want to do is set the current level, set it to 1. We want to load our bricks. bricks equals, I want to call load level self. Sorry, I got interrupted with somebody at the door. Where were we? We're loading our bricks from load level. So self.levels self.current level -1. We use -1 because our current level is actually 1, but the first item in our levels will be 0. A list or an array starts at 0. So that should load the bricks from level 1 into self.bricks. We want to reset the ball, self.reset ball, set our current game state, game state ready, start new game. So what we can do is run self.start new game right here. We can set the current game state to none. We'll just initialize it as none because we're going to set it in start new game anyway. Bricks is none. Current level, none. Okay, I think that will load level 1 and show us, what was it, 6 bricks along the screen. Here we go. Alright, we've thrown an error. So let's have a look at that. So with open in our brick, line 72, with open assets plus level as F, it says can only concatenate string, not list to string. That probably means that we are sending a list rather than an item from the list. So let's look here, load level, self.levels, self.current level -1. So that should be an item in the list. Levels, we should be populating here. Let's have a look at check levels. Fair levels.append line.right. So we've accidentally got right split here. That will create an array of items from that line. So we want strip. That was an error. That was a bug. I think that should fix it. Bam, there you go. And there's the 6 items from that level file. Cool. Now let's make some more levels. Let's create a level2.text. Now I've already got something for this, so I'm just going to paste it in. You can copy it. We're using 1s, 2s, 3s and 4s, so all of our brick types. I've left a gap in here. I've kind of shaped it a bit. And then level 3. Let's just do a big block of bricks. You don't have to worry about spaces on the right hand side. All it cares about is left hand side. So when you're creating these, remember that our bricks are 32 wide and our game screen is 384 wide. So 384 divided by 32 is 12. You can get 12 bricks across the screen. If you look at level 2, you'll see the bottom 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, are actually 12. So the bottom 2, the first 2 rows should be all the way across the screen. Remember to update your manifest file, so level2.text, 3.text. Now if you actually spell one of these wrong or you add something and the file doesn't exist, then your game's probably going to crash. So don't do that. You can come in and add some checking to see if, you know, the files actually exist before adding them to the array. I might do a separate video on how to do that. But for now, we've got 3 levels. We've got no way to get from level 1 to level 2. So what we want to do is, every time we break a brick, check if we've broken all the bricks, and if all the bricks are gone, then progress to the next level. If we're actually on the last level, then we want to just change it to the win state. So in our main, let's go down below our collisions. Let's create new function, call it check level complete. Now, if the length of self.bricks is equal to 0, so if we run out of bricks, and if the length of self.levels is greater than self.current level, so if there's more levels than the current level, then start new next level. That function doesn't exist yet, but we'll create it shortly. Else, so if there aren't any more levels in the list, we're going to go self.current game state equals game state.win. So up here with our reset ball and start new game, let's create our new function, start next level. With that, we want to go self.current level plus equals 1. So we're going to add 1 to the level. We go self.bricks equals load level. Same as what we did in start new game. So levels self.current level minus 1. We want to set the game state. Current game state equals game state dot ready, so we can shoot the ball. Self dot reset ball. Now, if we break all of the blocks in a level, we want it to check if the level is complete. Hang on, there's a typo here. Start next level. We should have an underscore between each word. So in our collision detection, I think when we break a brick, we should check if we've completed the level. So after we've deleted the brick, let's go self.check level complete. Now I think if we break all those first 6 bricks, it should load the second level. Let's try it. Bear with me while I break these bricks. Maybe we should have made it so there was only 1. Bam, there's level 2 and we've gone back to ready state. Awesome. Ready to play again. Now, breaking bricks is one thing, but let's get some points for doing it, eh? So in our ball class, in our detect collision, what we can do is if we break a brick, we can work out what the value of that brick is and send it back to the main class. So at the top, let's say score equals 0, so that's what it'll return to start with. Let's come down the bottom and make it return it. So returns false and score, turns true and score, so it did collide and here's the score you got. And there's another return up here. If the ball's not moving, score. So we're always going to return score, but we need to work out what the value of score is. So if we hit the paddle, we don't get any points, but if we hit anywhere on one of the bricks, we do get points. So we can go score equals obj.score. Now we're going to use this in each of the sides. It's a little bit verbose, we could probably tidy this up, but at least as we read through it, we know what it does for now. Nice. Now we're working out what the score is of each brick and we're returning it. We need to actually use it. So we go back to main. When we check collisions, because it's returning both whether it collided or not, as well as a value for score, if we're checking the paddle, we don't care about the score, so we'll just save it in underscore, that means we'll just ignore it. If we're checking bricks, then we do want to know what it is. So let's call it score. Now if collision, self.score plus equals score. So add the new score. Let's actually add a score variable in here. Self.score equals 0. In fact, let's set it to none and set it in new game. So self.score equals 0. Now, we've got no way to see the score. We'll do a proper title shortly, but for now, let's just show it underneath this debug text that shows us what our game state is. We'll move it down a bit. So pixel height minus 10, string of score. Let's run it again. Current score is 0, 1, there we go. Cool. Next, I want to add some lives. So when we drop the ball, we want to lose a life. Let's add lives up here. Self.lives, make it none. We're going to initiate that. Self.lives equals, will give us 3. We put it in start new game because if we fail, we want to be able to start again and give us 3 new lives. In update, when we check if the ball has gone out of bounds, we want to remove a life. So lives minus equals 1. Now, if self.lives is greater than 0, then we can do the dropped business. Else, so if we don't have any lives left, we want to set game over. So self.current game state equals game over. Okay, so let's drop some balls. So it should go dropped, game state dropped. Let's drop another one. Dropped. Do another one. Says game over. We've dropped 3 balls. It's now game over. Now we've got no way to restart the game at the moment, so let's fix that. We'll do that in input. Check input. So if current game state is equal to game over, we'll also add the win state. So if you actually finish everything and win the game, we want to be able to have a way to start it again. So self.current game state is equal to game state.win. So if it's either game over or win, you want to check for the enter key. So if Pyxel dot button pressed, dot button pressed, Pyxel dot, they call it return key. I'm going to go self dot start new game. Now let's get to that game over state and see if we can start a new game. It's 1 ball, 2 balls, 3 balls. We're in game over. If I click, it does nothing. If I press enter, loads a new game, sets our score to 0 and puts us ready again. Now let's get around to putting some text on the screen. Because we actually want to show the score and how many lives we've got left. We'll show that at the top of the screen. But if we drop the ball, or if we go to game over or win, we want to show a bit of a screen with some instructions. So if you drop the ball, it'll say, drop the ball, click or space to continue. Let's put all of those into a separate file because it's a little bit to type out. Let's keep it tucked away. So Breakout, let's go new Python file. Let's just call it HUD, or head up display. Importing Pyxel as usual. Now we're not creating a class in here. These are just functions that we're going to be able to call. Now because we sometimes want text centered in the middle of the screen, or we want text aligned to the right of the screen. I'm going to create a couple of helper functions that will give us the right X coordinate for where to put our text. So we want helper function for calculating the start X value for centered text. Let's give it a helper function. My typing's atrocious today. So center text, it'll want the text, and it'll want the character width, which for us will just be font width. Pyxel doesn't have a way to load new fonts or change the scaling of fonts. If you want custom fonts, you can load them into a tile map and create your own functions to write them out. I'm going to create a different video on that. For now, we're just going to use the default text and it'll do us. So text width, we need to get the width of the text equals the length of the text that is passed in times character width, of course. And we want to return pixel.width, so the right hand side of the screen, minus text width divided by 2. That will center whatever text we pass into it horizontally across the screen. Let's create another one called right text. The function for I'm doing this because these are two functions that you might want to use in all of your Pyxel projects. So just come and copy and paste them. So it wants the text, it wants the character width. You can pass in the character width if you're giving it a custom font, but otherwise we'll just, if you don't pass anything in, it'll just use the default font width that Pyxel supplies. So text width again equals length of text times character width. Just adjust that typo there. Now this time we want to return pixel.width minus text text width plus character width. So we want to return the right hand side of the screen minus the width of the text plus another character. We don't want it sitting right on the edge. And we also want to spell return correctly. Ret run won't do anything. Alright, there's our helper functions. We'll use them within this HUD module. The first thing we want to do is draw the actual HUD, which will be, the score and the lives left. So def, let's go draw HUD. I'm going to pass in the score. If you don't pass it in, it's just going to be 0. Pass in the lives, same thing. Let's go draw score, pixel.text. I want to put it 10 across and 5 down, so top left corner. We're going to say score. We're going to concatenate the string value of score, because score is an integer. We need to turn it into a string. And make it the color white. Now this is complaining because it's not indented. Now we actually want to draw lives. I want to put that on the right hand side of the screen. So let's just create the string here so that we can pass it to our right align function. Lives plus string of lives, and then we can go pixel.text right text lives text, give it the lives text. We want it 5 down from the top. We want to actually print lives text and color 7, which is white. If you want to check the colors or any of the Pyxel API, come to github.com/kiteo/Pyxel. There's a good write-up, there's a whole heap of examples, but here's your color palette. You can see 7 is white. So if you wanted to use green text, you could use 11, 10's yellow. There's instructions on how to install it and get your project running, some examples, and the APIs down here. Input keys, graphics, using tile map, camera. You can set different palettes for different colors. You can draw circles and ellipses. Yeah, it's good to draw that. Back in main, right up the top, I want to from HUD import draw HUD, and then down in draw, let's put it last so it gets drawn on top of everything else. So we can go draw HUD and pass it the score. Self.score and lives equals self.lives. If we try that, you can see we've got score on the top left, lives in the top right. Score goes up as we kill bricks, lives goes down as we drop balls, and they should reset when we start a new game. Here we go. Now what else do we want in our HUD? We want to show, when we drop the ball, we want to show a bit of a screen. So let's go draw dropped. Title equals drop the ball. Let's make it caps. We're going to have a subtitle equals click or space to continue. So Pyxel.text, and we want to center these, so center text title. Now where to place it vertically, I want to go Pyxel.height divided by 3, so it'll be the top third of the screen. The text will be title, of course, and the color is white. Let's draw our subtitle, so Pyxel.text, center text, subtitle, Pyxel.height, let's go divided by 2, so this will be halfway down the screen, the subtitle. Subtitle 7. Now back in our main, we should import draw dropped, and down in our draw, what we can do is if self.currentGameState is equal to GameState.dropped, then draw dropped. Let's try it. Let's drop a ball. Bam! Drop the ball, click or space to continue. There you go. Now let's do another one for game over. So HUD, draw, game over. Let's get the score this time, so we can tell the player how many points they got on their game over screen. Let's go title equals game over. Score text equals you scored plus string of score plus points. And then let's go press enter text equals press enter to try again. Now pixel.text, let's draw the title, centered, so center text, title, Pyxel dot height divided by 3, so a third of the way down, title, white. Let's do the score one, text, center text, score text. Now this one, let's go pixel dot height divided by 12 times 5. So we'll break the height up into 12 sections and we'll come down 5 of those sections. 6 of them would be halfway, 5 of them would just up from halfway. We're going to use score text and col7 will do us. Pixel.text, now this is the press enter text, center text, press enter. This one can just be halfway. Pixel.height divided by 2, press enter text, 7. Now, to draw our game over, let's import it. Draw game over. Let's do another if. So if self.current game state is equal to game state dot game over, draw game over. Send the score equals self dot score. Now let's try it. Let's quickly get into game over state. Drop the ball. This one should say game over instead of dropped ball. Game over. You scored 2 points. Press enter to try again. If I click, it does nothing. Press enter, it starts again. Oh yeah. Now the other thing that we can draw is win. If we complete all the levels and break all the bricks on the last level, I want to show a win screen. So def draw win. Let's have our score again. Title equals you win. Score text equals the same as this one. You scored the string of score points. And then let's do the press enter thing again. Like that. In fact, this whole section here will be exactly the same, because we're using the same variables. There you go, you win. Let's import it. Draw win. And if self dot current game state equals game state dot win. Draw win. Score equals self dot score. Now what we can do to test this is, let's just go to our levels manifest, get rid of level 2 and 3, and go and simplify our level 1. Try again. So it should only be 1 brick to break, then game over. Boom, you win. You scored 1 point. You scored 1 point. Press enter to try again. Now we've got no input checker for the win state. We can fix that. Let's undo the changes here. Fix our levels up. In main, under check input. Actually, here's a bug here. Check input. We're going if current game state equals game state over, or current level equals game state win. That's wrong. Did you guys pick that up? There we go. Now, when we win, we should be able to press enter to start a new game. So right now, we have a functional game. We've got levels. We've got a ball. We can add new levels just with simple text files. We've got game state. If we drop the ball, we change to the drop state. We show a message. We've got the running state. We've got the game over state. We've got the win state. We've got scores, lives. We've got automatically loading the next level. What are we missing? We could use a bit of sound, hey? So two things. Let's get rid of these debug things down the bottom showing the game state. We don't care about those anymore. We've handled them all. And showing that score. So in main, in draw, we can get rid of these last two lines here. Blonk, gone. For sounds, we're going to want our resource editor again. This time, come across to the sound section. Now you see these key panels here. You can click in here to create notes, but they don't do anything unless you tell it what sort of note you want, right? So if I want a pulse, I click here, it should make a pulse sound. If I press space to play, you can hear the sound. If you put too much in, just press delete, backspace. So first thing, let's make a sound for when we hit the paddle. Down here. That'll do. Up here, that'll be sound 0. Next one, when we hit a brick. Let's make that a pulse as well. Up here somewhere. That's a bit high. When we hit a brick, it'll make that sound. Let's go sound 2. Now, when we drop the ball, let's make it a noise. So let's go like something like this. We drop the ball, makes a crunchy noise. We can come back here later and create game over and win sounds or music if we want. But these three will just get us started. Let's save. And close this. We've created sound 0, 1, and 2. If you want to know more about the different tones and effects and whatnot, open up that Pyxel page again and come down to audio. These are the different methods you can use. If you scroll up back to the resource editor, it tells you about sounds, how to make music from those sounds. So we want to create some constants. We're not going to use an enum because it's only good for comparing two things. We want to actually tell it the number. So let's create some constants. Let's go paddle sound equals 0. Brick sound equals 1. Drop sound equals 2. Let's make these uppercase. Change case, Control Shift U. So paddle sound, brick sound, drop sound. Now down in our check collision, when we collide with the paddle, we want to go pixel.play. We're going to use channel 0, and we're going to go paddle sound. Now we should be able to try it. There you go. Now let's add the brick sound. If we hit a brick and we get a collision, let's go play, pixel.play. There's the planes again. Brick sound. Let's do our drop while we're at it. Where do we check if we drop it? That's in update. So if out of bounds, pixel.play channel 0 drop sound. Let's try it. So you get the ding when we hit the bricks. We get the other sound when we hit the paddle. And we get the crash sound when we drop the ball. I'll leave adding the win sound and the game over sound to you. But update them in the same way. If you, in update, if we find out that you've dropped the ball and it's gone to game over, play your game over sound. How do we determine if we win? That's in check level complete. If we've won, you can play your win sound in there. Now we've pretty well got a whole game. It's one thing I forgot to do. I wanted to, after so many ball bounces, get the ball to increase speed. So let's go to our ball class. Above our detect collision, after update, let's add a function, speed up. And we want to know how much we want to speed it up, amount. So self.speedx plus equals, this is where we need that copy sign, amount self.speedx. Now, copy sign copies the sign of whatever you put here to the value that you give it. So the sign is, if it's a negative number, then it will return a negative number. If this is a positive number, it will return a positive number. So you want to increase the x speed by the amount, but if it's heading in the left direction, that's a negative number, so you want to increase it the other way. So copy sign lets you do that. Let's do the same thing for speed y. Man, self dot speed y. Now, when do we do that? Back in our main, we need to track how many times the ball has bounced. So up in our init, up here with the ball, let's go self.bounces equals, we'll just set it to none. Actually, let's initialize it as 0 because we don't need to set it in start new game because it calls reset ball, and reset ball sets the speed for us. So next we need to work out, we need to keep track of the bounces. So we're going to have to do that in check collision. So when we collide with the paddle, let's go self.bounces plus equals 1. Hold on, just thought of something. Bounces equals 0. We do need to reset bounces in reset ball. Self.bounces equals 0. Otherwise it'll start out fast. The first time you hit something it'll speed up. So check collision, self.bounces plus equals 1. And then we want to check speed up. We're going to have to create this function. Self.check speed up. We're also going to want to do this if we hit a brick. So self.bounces plus equals 1 and self.check speed up. Now let's do our check speed up function. Check speed up. So if self.bounces is equal to 4, so after 4 bounces, we'll go self.ball.speed up by a factor of 1. If self.bounces is equal to 12, self.ball.speed up by a factor of 2. These are actually the original rules from Breakout on the Atari. After 4 bounces it speeds up, and after 12 bounces it speeds up. In the original game there are other reasons the ball speeds up. If it touches the top wall, or if it hits one of the yellow or red bricks, orange or red bricks, it will speed up. But we're just going to do it after so many bounces. I think that should work. So 1, 2, 3, 4, it's sped up. 5, 6, 7, 8, 9, 10, 11, 12, it's sped up again. Now it's going pretty fast. Even though it's going pretty fast, it should not go straight through a brick. We start a new level and we get back to the normal speed. If we drop the ball, it should just go back to the starting speed. There we go. This gives us more or less a complete game. If you think I've done something wrong, or you've got some better ideas on how to solve some of these problems, feel free to put them in the comments below. If you run into any problems, or you'd just like to share your version of the game, hop into the Discord. I'll have it linked in the description. Thank you very much for watching. Stay caffeinated.